Welcome to 4.7, Graphs of Linear Inequalities. Two objectives here: verify solutions to an inequality in two variables and to graph linear inequalities. Again, draw your attention to the word inequalities. Inequalities will employ less than, greater than, less than or equal to, greater than or equal to symbols. Inequality means one side is more than the other. And this means you will not get an exact solution. You're going to get a host of solutions. So you have a huge interval of solutions that will work for inequalities, right? So that's a recap from what we've learned about linear inequality in one variable. Here we're talking about linear inequality in two variables, which makes a difference. Right now we're going to graph this linear inequality not on one number line, but on two number lines, which is our XY grid. Okay. All right. What is a solution to a linear inequality? Just like equations, your solution must make the statement true, which means it must keep the inequality true. Okay. So here comes our first problem. Determine whether each ordered pair is a solution to the inequality y greater than x plus 4. So let's take the first one, 0, 0. And let's write the inequality y greater than x plus 4. Kind of segregating the sections. So I have to plug in for y and for x. Now it's ordered pairs, so you know what goes where. So y takes 0. In fact, x also takes 0. Okay. 0 greater than 4, right? 0 plus 4 is 4. Now you need to see if this makes the inequality true. Is 0 greater than 4? Is that a true statement? No, it is not a true statement. Actually, 0 is not greater than 4, right? So I'll come down here and say not a true statement. What does this imply? Well, it implies that 0, 0 is not, it's not a solution to the inequality, of course. Okay, now let's try this with 1, 6. 1, 6. Y greater than x plus 4. Shell for y or shell for x plus 4. We'll do a column there. Let's plug in. Y is 6, so 6 there, and x is 1. 6 is greater than 1 plus 4, 5. Is 6 greater than 5? Yes. True. This implies the point 1, 6 is a solution. Okay. We have plenty of solutions because it is not a single point, but it's a shaded region that is the answer. Remember that from our inequality lesson? So it's a shaded region. So in that shaded region, any point, you have infinite points there. So any point could work. And this one works, which means this is in the solution region. Okay, let's do 2, 6. Y greater than x plus 4. Let's draw a column there. Shell plus 4. 6 here and 2 here. So 6 greater than 2 plus 4 is 6. That's tricky. 6 greater than 6, is that true? Clearly false, right? It would have been true if we had a little equals bar here beneath the strict inequality, right? If there was something like this, oh yes, that would have worked. But we don't have the inequality bar, we have a strict inequality, which means this is a false statement. An X for the false, which means your 2, 6 is not a solution. Okay, let's take -5, -15. y greater than x plus 4. Y is negative 15 and x is negative 5. Look that we put the shells, so it takes care of the signs carefully. And never forget that, especially with inequalities, it's as it is tricky. You don't want to, compound the problem. Negative 5 plus 4 is negative 1. Okay. Is negative 15 greater than negative 1? When you have questions like these, some of you are very clear-headed, so maybe you're getting it. But for those who are getting confused with these things, I recommend that you do a number line. Okay. So your 0 is right in the middle, and you have negative numbers on the left and positive numbers on the right. So negative 1 is somewhere here, like that. If you go to 15, negative 15 is somewhere here. Remember, your numbers increase from left to right, isn't it? The numbers become larger from left to right. So the more left you go, the number's value is actually very small. So negative 15 is very small compared to negative 1, right? But the statement here says negative 15 is greater than negative 1. So is that true or false? Quite clearly, it is a false statement. So when you're in doubt, please use the number line. So this is false, which implies negative 5, negative 15 is not a solution. Okay. I will leave the last part to you. You could do that as an exercise. Okay, we move to graphing linear inequality. Well, we have some steps, so let's look at that. This is a very important step for us to follow. If the inequality is less than or equal to, if you have that equals bar, right, the line has to be solid. Boundary line, which is the line that you're graphing, has to be solid. And if your inequality is strict, which means there's no equals bar, the line must be dashed. Okay. Dashed means the line itself is not part of the solution. If the line is solid, it means the line is also part of the solution. We're going to shade the region. We need to know if it is included or not. This is very, very similar to our bracket and parentheses, the solid dot and the open circle. Right? We did all that in a single number line when we had one variable. Here we have two variables. So you're going to draw a line and then decide if it has to be solid or dashed, which means you have to decide if it is included or not based on the inequality symbol. Then we need to use a test point. Again, when I do a problem, you can understand that. A test point will tell you if it's a solution or not. When you plug in the test point in your inequality, if it comes out to be true, you will shade that region where the test point is. Okay. If the test point is not a solution, you will shade in the opposite side. Okay. So we have like 3 steps. Let's come here. Graph the inequality, x minus 2y less than 5. Okay. Well, I have to first graph it, so let's go to the first step. It says identify and graph the boundary line. We need to graph this line, right? So we need to kind of rewrite this as if it was an equation, right? Because we need to graph this. We want to do it by looking at it as an equation as opposed to an inequality. So rewrite your inequality as if it was an equation so that we could graph it. It's only for graphing purposes. After that, we will get back to the original question, which is less than 5. Okay, so you could use the table method, or you could move it around into slope-intercept form and then graph it. But let's do the table method. So I'm using just the p part of the table, x and y. Okay. You could use the slope-intercept form as well. Okay, we could do that. So I want to use that to kind of highlight to you that you could do the table method by generating 3 points. You could do the slope-intercept form, or you could also do just the intercept form where x is a 0 and y is a 0, right? I just want to try this. And so we plug in And we need one more point, so I'm just going to put 1, okay, for the x. So 0, when x is 0, right, you have to solve it by the side. When x is 0, I'm going to just walk you through this. I'm not going to show it by the side. When x is 0, we have negative 2y equals 5. So divide both sides by negative 2. You get negative 5 over 2 as your answer. Okay. Your corresponding y value when x is 0 is negative 5 over 2. All right. You do the math so you can actually follow what that means. When you plug in y as 0, the middle term, this term goes away. So if this goes away, you're simply left with x on the left and 5 on the right. So x equals 5. That was a breeze. So x is 5. Then let's plug in 1 for x. Okay. This is the third point as a test point for us. So 1 is plugged in for x. So you have to subtract 1 on both sides. So you get 5 minus 1, which is 4. Negative 2y equals 4. Divide both sides by negative 2. So 4 over negative 2 is negative 2. Okay. Again, I said everything verbally so that you would work it out. And if you had any questions, you can listen to my verbal explanation of it. Okay, let's plot these points. And once we plot them, we're going to connect the dots to draw the line, right? When you draw the line, do we have to do a dashed line or a solid line? You see the inequality here. The inequality is strict. Strict inequality means it has to be a dashed line. Okay. So 0, negative 5 over 2. Well, our unit is, the scale of our graph is 1 unit each. Negative 5 over 2 is negative 2.5, right? So 0 and negative 2.5. So this is something I have to eyeball. So I'm going to plant it right in the middle here, right? 0, negative 5. These are, I use the intersect method. So obviously, this has x as 0. It must be my y-intercept. This has y as 0. This must be my x-intercept. I use that method, so I expect the points to land on the x and the y axes. 5, 0 is right here. And 1, negative 2 is right there. These points must line up now. Okay. You must be slightly alarmed that I have a solid line. Well, I cannot draw a dashed line right away, so I'm going to use a different technique to get the dashed line. Okay. Okay, good. And we will name it as x minus 2y equals 5. Okay. This is a dashed line, but remember, inequality means shaded region. Okay, let me write it somewhere nice and big. Inequality. When you graph inequality, it implies shaded region, not just a line. Okay, the equation means just a line. Inequality means shaded region. Now I have this line separating our grid into two parts, either the upper half, not half, upper part or the lower part. Which one should we shade? So we go back to the technique here. It says, step 2 says, test a point and see if it is a solution to the inequality. Test a point. The point should not be on the line because you don't want it to be ambiguous. We always like 0, 0 to be a test point just because it's so convenient to plug in 0, 0, right? So I'm going to write it out here. Our test point is 0, 0. It's a good point. And the inequality is x minus 2y less than 5. X minus 2y less than 5. Remember, we only did it as an equation for graphing that line. Okay, just for that. We just used the equation as a crutch to get past that hurdle. Now that we're done with it, we have to now focus on the inequality. And so x minus 2y less than 5 is what is given. Plug in for x and y as 0 and 0. 0 minus 2 times 0, so 0 minus 0 is 0. 0 is less than 5. Is that a true statement? Is 0 less than 5? Well, indeed, 0 is less than 5. Because this is a true statement, shade where the test point lies. The test point lies above the dashed line. So we're going to shade this region. Okay, this is going to be painful, but let's see. This is what I meant by painful. We are shading this whole region. The line is also seen, it seems as if the line is also being shaded, but we know very clearly it is not because of the dashed line. The dashed line tells us it's not part of the green shaded solution. Again, do you think you could write the solution? No, we really have no way of writing the solution. We only have a way of showing what the solution is. So the green shaded region is your solution. Isn't that cool? So your inequality gives you a shaded region that can only be seen visually, right? So with that, we come to the end of our section here. I will see you in the next video.